So quiz tomorrow. I just want to do a couple of examples so you guys will be prepped for what's going to happen. Here's one. I want to take the inverse transform. So I want to find y of t, a function of time, if the f of x, the transform, is 1 over s cubed. Okay. Getting out of the Laplace world, we use the chart. So the chart. So I'm looking for, s to the n here. This is what I'm looking for. So t to the n transforms to be n factorial over s to the n plus 1. And I've got s cubed, so s to the n plus 1. That's like n is 2. So if t squared would transform to be 2 factorial over s cubed. So, not bad. I got stuff going on here. All right, so I wish there was a 2 on top. So I'm going to put a 2 on top and a 2 on the bottom. So it's the same thing as my original question. And now I'm good to unLaplace. Y of t is going to be, this half is a constant, and this will be the t squared here. Done. So that one's not too bad. Let's take a look at this next one. This next one is more of a full question. I want to solve this, there's the answer, but I want to solve this using Laplace transforms. Now it's a chapter 4 style question. We could answer this with get the homogeneous, so we could get the homogeneous solution, in which case we would want to get our auxiliary equation. And that'll factor into, that should factor into lambda minus 2 all squared. So I get real and repeated eigenvalues. So looking at this the chapter 4 way, I get eigenvalue of 2 and 2. So I expect to have one piece with c1 e to the 2t. There's my c1 e to the 2t, there's my answer, and also a c2t e to the 2t. So this is my homogeneous solution. We've already found the constants. Now, to this homogeneous solution, move that over here, I'd want to add the particular solution. Well, my target function is e to the t, 3e to the t. I wouldn't do variation of parameters here, although I could, but it's too much hassle. I would do unknown coefficients, and my guess would be some constant e to the t. So just from the eigenvalues and my target function, I know my answer is going to be some number e to the 2t plus some constant t e to the 2t plus some constant e to the t. The constants, the minus 3, the 4, and the 3, we would find that by invoking, well, no, the 3 we would get from unknown coefficients. The other constants, the minus 3 and the 4, we would get by invoking the initial conditions. But we know what the form is of our answer before we even start to do Laplace. But the question wants us to do Laplace. So let's just get this out of here, and let's do our Laplace. So I'm going to Laplace the equation. First thing is to take the Laplace of y prime prime. So again, I'm back to my chart. The derivatives, the Laplace of, okay, here's the Laplace of the nth derivative would be, so I'm taking the second derivative. So it would be s squared f minus s f naught or y naught minus y prime naught. So I'm taking the derivative of y prime prime. That's going to be my s squared f minus s y naught minus y prime naught. That's my transform of y prime prime. I'm going to put the constants in a minute. Minus 4 times, now in this bracket is the transform of y prime, which is sf minus y naught. And finally, the transform of y is f. Now I transform the whole left-hand side. Let's transform the right-hand side. The transform of 3e to the t from the chart, this one you have memorized because you did it so often in your homework, 3 over s minus 1. Okay, so now I've done the transform. Let's put in our initial conditions. Y naught being 0, that's, oh, this is a plus, duh. That's going to be nice. When y naught is equal to 0, this disappears. Y prime naught is 1, so here where I'm absorbing the initial conditions. Y naught is equal to 0. There, I've put in the initial conditions. Now I just need to solve this expression for f. So anything that doesn't have an f on it, like this minus 1, is going to go to the other side, get out of here, and become a plus 1. Now everything left over has an f, so I'm going to factor out that f. So f times what's left when I factor out? I'm going to have an s squared minus 4s plus 4, and that equals to this side here. Okay, now wait a minute. There's a familiar piece of algebra, s squared minus 4s plus 4. That's the auxiliary equation. It shows up in the algebra, makes me feel like things are going well. It's the math expressing the eigenvalues of 2 and 2 through the Laplace method. Now I need to solve this for f. So when I solve this for f, I'm going to get f equals, and then I'm going to untransform both sides. So f equals, I'm dividing this whole piece out. Now I'm just, because I'm lazy. Yeah. All right. Lazy, but then it gave me a foolish way to... This, let's factor this then. This is s minus 2 all squared. So I'm going to divide that square bracket out, but it's really s minus 2 all squared. So I'm getting times s minus 2 all squared. And this 1 also gets divided by s minus 2 squared. So now I've solved for f. So what I want to do is break this into pieces and unlaplace it. I think it would be, I'm going to need to do partial fractions here. But the general strategy I use is it's better to just put this together into one fraction and then do partial fractions once rather than do partial fractions twice. Although in this case, I think it's not going to make any difference. But I'm just going to do what I do, the method. So let's common denominator this together. I need to multiply top and bottom of this fraction by s minus 1. Multiply the bottom also by s minus 1. And now I can put them in, I can add them together into one fraction. So f is equal to, when I add the tops together, plus 3, so that becomes minus plus 2 here. Right, when I add the 3 to the minus 1, I get a plus 2. Now I want to break this up into partial fractions. So one of the pieces is going to be some number over s minus 1 plus, now I got repeated factor, So I want some number over s minus 2 and some number over s minus 2 squared. No. But I still had that saved. So now partial fractions is going to get me the a and the b and the c. So you guys know how to do partial fractions, but let's say I get numbers for a, b, and c. Now let's unLaplace things. The f is going to unLaplace to be y. The a, s minus 1, is going to unLaplace to be e to the t. B times, here's s minus 2, that's e to the 2t, right? We're using those chart rules. And now this c, I need to unLaplace this one. This one we got to take a little bit of care for. Let's go back to the chart. I see s minus 2 squared here. I'm seeing, there's two ways to see this. This is like the derivative if I differentiated 1 over s minus 2, I would get minus this. Or another way, let's look at the chart while I'm talking here. So if I think about it as the derivative, then it's going to be t times the original function, the original e to the t. Or if I think of it like this, if I'm unLaplacing s minus a, so I think I'm going to think of it, I'm going to use this rule. I'm just putting this rule here so I can look at it. Okay, so I'm comparing this piece here. The c, that's just a constant, that's not doing anything. The s minus a, it looks like the a is 2. So if the a is 2, then I'm going to multiply by e to the at. And if the a is 2, then 1 over s minus 2 squared is the shifted function. The original function, the original f, should be equal to 1 over s squared. Should be the original function. Right? Because then s minus 2 would be that s minus 2 squared. So the original big F is 1 over s squared, which makes the original little f t, because t transforms into that. So I want to multiply that by t, but I'm just going to put the t here. So I could have used, I did use this rule. I could have also used this rule. Long story short, I've unLaplaced it. Sure, you're saying you don't know what the a, b, and c are yet, except if I would have done partial fractions, I would have had numbers for a, b, and c, and I already kind of do know. When I did if I do partial fractions, it looks like the a is going to be 3, it looks like the b is going to be minus 3, and it looks like the c is going to be 4, because that's my answer using the chapter 4 way. Just to prove it, if I did do partial fractions, calculus, partial fractions. Yeah, it gives me the minus 3, the 3, and the 4. It breaks it up like that, like I want to. Anyway, good luck on the quiz tomorrow.